they're very much formula based. So the relationship between, you have an angle, you have a radius, you have an arc length. For some reason they use S. S equals r theta, but theta is in radians, which is weird, but that's the way it is. So in your problem, 8 is your S, your radius is 5. Theta is in degrees though. So they actually don't even, well, I actually take that back. Maybe they're not. So your theta is 8 divided by 5, which is 1.6. So I guess it's that. All right, so next question, of course, is to find the area of the sector. Let me get that snipped in. It's a very, very similar formula, related formula. Okay, find the area of the sector. So the pizza slice, okay? So the area of a circle is pi r squared, okay? Oh, they're using this one, okay. So there's the other formula for this, which I don't know. I only use the one with angles, angle over 360, 180 over pi. So you get, what do you get? Times 180 over pi. 1/2 theta r, 1/2 theta r squared. Does that look right when it's in radians? Okay. So that gives you 1/2, 0.4, 10 squared. 100 times 0.4 is 40. Half of 40 is 20. Looks like that's it. So really, you got to know your formulas. You got to be able to come up with them. Do you get a formula sheet?
I think we do.
Okay. So some of these are good to put down.
Okay.
Maybe even the one up here. All right. So yeah, this one's weird in that you actually want this other arc, not the little one. So you actually need this angle over here. It's 360 minus 115, which is 245. So the formula for circumference is 2 pi r, but what I prefer to do is make it when it's in degrees, say it's a ratio, or no, I'm sorry, it's a fraction of 360, so it's part of it. So for you, that's 245 over 360, 2 times pi times 5. There is a formula for this with it in radians, which I don't know, but we can figure it out. It's you multiply this by 180 over pi, so those cancel. So it's theta r, but you'd have to convert this to radians.
Okay.
So that's the alternative way to do it. Is say, okay, well, it's 245 times pi over 180 times 5, and you get these are the same.
Okay.
And you get a calculator. You get a normal calculator, I assume, TI-83.
Yeah.
Okay, I'll try to remember that because there's some problems where you just use the calculator to do this.
Okay.
Better. All right, number 10. So when I see that you've been given like two problems of kind of the same type, you're going to get one like that on the final, you would think. I think 8 was kind of like this one. Yeah, 8 was an area, 10 was an area, 7 was this. Well, 7 was the angle, 9 was the arc length. So just keep that in mind. So the radius. So we have the area of the sector is 10. Okay, so the area of the sector is, and if you're doing it in what is it, 1/2 theta r. So we know that that's 10 1/2 theta is 0.8. And there's your R. So you just solve for that. That's whatever that ends up being. I'd get a calculator just to avoid making some mistakes. Let's see here, 20 divided by 0.8 is 25, which is not there. Oh, is it squared? Yeah, sorry, it's squared. So you gotta, it ends up being 25 equals R squared, R equals 5. All right, so I found the next kind of page in order here, number 11.
Mm-hmm.
Number 11 is a formula. I don't remember this, so I'm gonna have to look it up. It's on this trig cheat sheet that I like.
Mm-hmm.
It's oh no, I'm sorry. No, I'm sorry. They're just asking for the values. Okay, I'm sorry. So on the unit circle here,
Mm-hmm.
they're telling you, oh, you're over here. And there's a lot of ways to remember this, but this is just a unit circle answer. Another thing that could help here is all students take calculus, which tells you that only the sine is positive in that quadrant. Cosine is negative. Actually, doesn't help. That gets you rid of one answer. So I don't know. I mean, these are numbers on the unit circle. So
Yeah.
it's root 2 over 2, but the cosine is negative.
Mm-hmm.
Where is it, right? So it looks like it's that one. So you got to know your unit circle. Do you have the ability to memorize that? Do you?
I think he's going to give us the unit circle on the
Okay.
exam.
All right. Well, I'll go with the fact that you're going to have one here for the next few questions.
Mm-hmm.
I'll even pull one up here. So the tangent of 7 pi over 6 is the sine of 7 pi over 6 over the cosine of 7 pi over 6. And so on your unit circle, you'll see that's in the third quadrant. X is the cosine value, Y is the sine value. So it's minus 1/2 over minus square root of 3 over 2, which equals, whenever the bottoms are the same, you can just write it as a ratio.
Mm-hmm.
Like that. And then you have to rationalize here, multiplying the top and bottom by root 3. So you get root 3 over 3. So that gets us down to A or D. Tangent of 5 pi over 3 is, again, it's sine 5 pi over 3 over cosine 5 pi over 3. And so sine is the y value. So minus square root of 3 over 2 over 1/2. This ends up being just minus root 3. So it looks like that's your correct answer. If you have a calculator and you put your mode in radians and you put the decimal, put the root part also in, you can also match it up that way.
Okay.
As a backup. That's why I asked, because calculator really saves you a lot of like remembering in some cases. 13 is really similar, so we might as well skip that. We'll go to 14 if that's okay with you.
Yeah, okay.
So if you had a lot of extra time on the exam, you could just graph the ones in here and see which one matches.
Mm-hmm.
I'll point out that sine starts at 0.
Yeah.
And does this. So it's probably a sine. So that's out and that's out. And then how high does it go? Well, it goes 15. How low does it go? 15. So that's its amplitude. The period we could figure out if we needed to, but you try to go for the easier stuff first. So it's and what might be tough here is we actually need its half. We're only given its half period. Its half period is 2 pi. So its full period is 4 pi. And then a period equals b, 2 pi over b. So that's how you could solve for this 1/2 if you needed to.
Okay, perfect.
But this is important. Or b equals 2 pi over the period.
Mhm.
That's also a good one. I mean, they're the same, but they're just written slightly differently. All right, so next one here. $15. All right, so find the equation and period of the graph. I think the period is easier to see because you're looking for like how often does this repeat.
Mhm.
Actually, well, I take that. It's kind of they don't really give you the nice information here, but like I don't know what this is. So between minus pi and pi, there's two of these, which means that they occur every pi because you get two of them for 2 pi, so 1 per pi. So that means it must be period 1 pi. All that does is get rid of that. And then the question is, well, which graph goes up and to the right? Could be tough to answer that. It is kind of clear that there's some sort of a shift on one of these because it doesn't go through 0. So that means this one's probably out. And so this one over here, this third one is pi over 4 left. And this one on the right is pi over 4 right. So what do you see here? Which one is it shifted left or right, do you think?
I think it's shifted right.
I'm sorry. And they're also cotangent and tangent. That's also a huge difference here. So the graph of cotangent is the one that goes through 0 or doesn't go through 0. It looks like this. So it's actually the one that's shifted left.
Oh.
And I thought well, maybe she'll see that because if it were shifted right, it would be over here. You know, you would see it kind of over like that.
Mm-hmm. Oh yeah.
I would probably graph these. Like if my grade depended on it, I was a student like you are, just to be sure.
Okay.
If you have time.
All right.
$16 is kind of the same. So let's move away from that and move to 17. We can always come back if we get done with everything. All right, which of the following values of the trigonometric functions of theta are true from the information given? Okay, so it says that secant of theta is 7 and sine of theta is less than 0. This is a problem where they want you to determine which quadrant you're in. So sine is negative. Did you see this in class this year?
Yeah.
Okay, so the sine is positive for sure in the top left and the top right because they're all, but sine is negative in both of these. Now secant is really like cosine. It's 1 over cosine equals 7. So where's cosine positive? Well, it's positive in the first quadrant and the fourth quadrant. So you look for the one that has the overlap. And then there's what I call this reference bow tie. These triangles are the triangles used depending on which quadrant you're. So since you're in quadrant 4, we're going to use this triangle right here. So it's better to kind of rearrange this to where you flip both sides. So cosine theta equals 1 over 7. This is your theta adjacent over hypotenuse. So 1 over 7. And then this is the square root of 49 minus 1, or 7 squared minus 1 squared. So it's the square root of 48. 48 reduces to 2 and 24, 2 and 12, 2 and 6, 2 and 3. So it ends up being 4 square root of 3, but it's negative. And it's negative because you're going down. So what's unfortunate here is that you have to look at all of them. to decide which one is true. I would tell you to start from the bottom up. That's just a strategy. So cotangent of theta. Cotangent of theta is, so tangent would be this opposite over adjacent. Cotangent's the flip of that. So it's 1 over minus 4 square root of 3.
Mm-hmm.
And wouldn't you know, that is the one that's true.
Mm-hmm.
That was a lot of effort.
Yeah.
18 is similar. We should do that though. It's I'm sure seeing another one will help.
Okay.
All right, which of the following values of the trigonometric functions of theta are true? Okay, so they tell you that you're in the third quadrant. So that's good. That means your triangle, you already know what it looks like. It looks like this.
Mm-hmm.
Okay, and then it's weird. I'm looking at the sprite here. So let's go with this. Okay, if tangent of theta is 6, that means opposite over adjacent is 6. So 6 over 1. But to get there, you're going left, which makes that negative, and you're going down, which makes that negative. And then this becomes the square root of 37 because you square that and you square that, which I think is where this is coming from. Like they're trying to tell you, but these are actually wrong because they're both negative. Anyway, so again, which of the following start at the bottom? Secant of theta is really 1 over cosine of theta. So cosine of theta is adjacent over hypotenuse minus 1 over the square root of 37. So we can flip both. We can flip this on the right. It becomes minus square root of 37. You can see that one's positive, so it's not that.
Mm-hmm.
But the cosine of theta, we just actually did that one. The cosine of theta is adjacent over hypotenuse. It is minus 1 over the square root of 37. So we have found that one. Always better to go that direction. All right, before I do the next one, let me snip in cofunctions.
Mm-hmm.
There's a pattern that's really important to see. Come on, where's the mouse? There it is. All right. So I want you to look at the right side, the right side here. Do you see how cosine theta, there's a theta there, and then its cofunction is pi over 2 minus theta.
Mm-hmm.
This one's theta, and then pi over 2 minus theta. So basically you take the reciprocal thing, and then the angle is 90 minus that angle, always. And if you don't have to remember the formulas, you just have to remember the format, that it's the reciprocal 90 minus the angle. So when you're in your problem, you're given cosecant. Now I know I've got it up here, but the reciprocal of cosecant is secant, or the matching one here. So this is secant, and then it's pi over 2 minus pi over 6. See how this angle just plops right in there?
Yeah.
So this is 3 pi over 6 minus pi over 6. That's 2 pi over 6. So it's the secant of 2 pi over 6, which is the secant of pi over 3. Boom. Now, I've said a lot here, but if you got a calculator, put that in the calculator, put that in the calculator, compare. If they allow calculator, make sure your mode, and this is very important, before you do any calculation, always check your mode, make sure it's right, radian versus degree.
Mm-hmm.
That will mess you up big time if you're not paying attention. Mean instructors will give you both answers, or give you wrong answers that are, that you think are right. A lot of effort to do that. So.
Mm-hmm.
All right. 20 is the same. So let's go to 20, 21 here. Find the reference number. I think what they really mean is reference angle here, determined by t equals 19 pi over 6. So you're looking for a lot of things. You're trying to figure out which quadrant you're in, but you may right away see that this is bigger than 2 pi. I don't know if you see that or not, because 2 pi is 12 pi over 6, which means you're actually going all the way around the unit circle at least one time, maybe more. So you can always look at its coterminal angle by subtracting 2 pi, which in this case is 12 pi over 6, which is 7 pi over 6. And that helps because it helps you to figure out, well, where am I? Where am I in the unit circle? Well, 7 pi over 6 is right there. The reference angle is always the angle that's made with the x-axis. So here you actually go back to get that reference angle. So it ends up being pi over 6. Now there's formulas for every quadrant, but there's formulas for every quadrant, whether you're going clockwise or counterclockwise, degree or radian. I think it's better to draw a picture and try to just figure out, well, am I going backwards or am I going to keep going? Mm-hmm. But it's always made with the x-axis. It's always the smaller one because there's another angle that goes this way, but that would be it. So let me know if that's not clear. We can do another example or two if you would like.
No, I think that makes sense.
Okay. So before we do 22, I'm going to just send this in the chat here because I just making sure that you have this at some point. This exam covers everything on this thing that I'm sending you. And the next problem refers to the Pythagorean identities. So if you don't know the Pythagorean identities, you have zero chance to do this. So I would just, if you're going to take more math, you will need to know this stuff, but you can relearn it whenever you need that again. But for the exam, you definitely need it because 22 is a Pythagorean identity. Or to ask you to look at a Pythagorean identity. So it says sine squared x plus 1 plus times 1 plus cotangent squared x. Whenever you see squareds, that's when you think of identities, squareds. So that 1 plus cotangent squared x is cosecant squared x. So we have sine squared x times cosecant squared x. Cosecant squared x is 1 over sine squared x, which is 1. But again, like if you were to graph this and graph like these, you would maybe see the one that's the same. You could also just put a number in for x and then a number in for x and see which ones match up. I mean, there's a lot of work to doing that, but it's like if you're uncertain, you can do some things like that. 23 is kind of the same way. Like when it's multiple choice, which I assume your final is.
Yeah, multiple choice.
Yeah. So the reason is, one of the reasons for that is they want to grade this thing quickly. Teachers want to be done, students want to be done. Like you can graph this, you can put a value in for x and compare it to one of these, or you can do it by hand, but you're not getting graded for your hand work. So just keep that in mind. So the other strategy is to put everything in terms of sine and cosine. So secant is 1 over cosine x, and cotangent, we're going to leave that as is. So see how these cancel? You get 1 on top. 1 over cotangent x, that's a reciprocal, that's tangent of x. So we could keep going here on 24, 25, 26. And if they were free response, they're all really good questions. I can't really tell you, as kind of an advocate for you that really should spend much more time on these. We should move on to other stuff unless you tell me otherwise.
I think we can move on. I think that's fine.
Okay. Let me go find 27. 27 is the same. 28. All right. Yeah, so 28, we'll look at. Actually, I'll just write it. So this is actually this is a very good question, because it's very difficult at first glance to even know how to proceed, because it's like negative 705. What is that? Well, if you add 360, that gives you the coterminal angle, and all that does is like wherever this is, you're just getting back to it. You're just rotating back. So that gives you minus 345. And then if you add 360 again, you get 15 degrees. So we really want the sine of 15 degrees, which is much more manageable. The problem does say use addition or subtraction formulas. So those again are on your reference sheet, which, boy, I mean, there's so much here. I don't envy, what you have to do here. It's a lot. So we want the one for sine. Obviously there's three, there's sine, cosine, and tangent. And you have to use like ones that work, like known ones. And it tells you to either add or subtract. This is like one of those things where I just have to tell you, unless you're a great guesser. It's 45 minus 30. And this is your alpha and this is your beta.
Okay.
So this becomes, we're doing this one right here. It becomes sine 45, cosine 30. So it is never this operator is never part of the number. It's always just the number. The plus is on top, so the plus goes with the plus, minus goes with the minus. Cosine 45, sine 30, which means you have to know your unit circle. Square root of 2 over 2, square root of 3 over 2, square root of 2 over 2, 1/2. So this becomes the square root of 6 over 4 minus square root of 2 over 4. So it becomes square root of 6 minus square root of 2 over 4. And again, another alternative, I didn't snip it in. The alternative is to just try try each solution. And I mean, there's a lot, like, I mean, there's just so much to remember here. All right, let me just need to do something real quick here, and then we can keep going. All right, so where to go next? Looking here. So 29 is the same. 30 is another formula. I guess we can do 30. Give you one of each. Oh, boy. No, it's another half angle. I'm sorry, it's another addition or subtraction. We shouldn't do that. It's just another one of these. Let's go look for 31. Make sure we get all the variations on this. That's the same. Okay. Let's go to 32 and 33. All right, so 32 and 33 use sum and difference formulas. they're going backwards. Okay. And again, like you could just type this into your calculator if you don't remember the formula. Now, if you do remember the formula, you will find that there's only kind of one reasonable option here, which is you're either adding the numbers, okay, or subtracting the numbers, but they almost always have to add or subtract to something that is nice. So in the case of 32, it's either the sine of 90 or it's the cosine of 90.
Mhm.
And the formula will verify that. And similarly with this one, it's either adding or subtracting to get it. Now, if you're good at memorizing stuff, you'll be able to see these pretty quickly when you do it. But I have to look at the formulas. I don't remember these because I don't use them very often. The second one is cosine, and it's minus, so this becomes a plus 3 pi over 4 plus pi over 8 when you're doing that. I mean, if there's a few you can be like, oh, it's not that, because those are weird. You never put a negative outside, but yeah, this ends up being this one. This is that one. But like I would just use a calculator. I mean, is that okay, or do you want more explanation?
Yeah, I feel like this would be easier if I have a calculator, but right now it's dead. So.
But you will have on an exam. It'll be fully charged, all that stuff.
Mm-hmm.
Okay. Yeah, because 34 is the same way. You would just use a calculator. Now, 35 is slightly different. We have to do a little work. You know, sometimes you just directly put the numbers in to get the answer. So a couple of options for like a problem like 35. If you just do the following, if you say x cosine x equals 0.3, and you have your mode in radians,
Mm-hmm.
and that kind of helps you, and you say x is the cosine inverse of 0.3, my guess is you're going to get either 1.2661 or 0.304, because and then you got to find the other one. So that's not a good strategy. The better strategy is to graph cosine. You graph cosine, it goes down and it comes back up, and here's 0.3, and see how it hits it twice.
Uh-huh.
You can find each of those values. Are you comfortable using secant, calc, intersect, or would you like me to show you that?
Just to show real quick, please.
Okay, let me get my calculator up. I didn't get that. All right, new share. All right, there it is. Okay, so this is an 83 plus. Yours might be newer, but it's very much the same. So mode, it's got to be in radian. Okay, so I go back to y equals, and I put in cosine x. I put in cosine x, there's x. And then I put in 0.3 and y2. Now, before you graph it, it's usually good to go to zoom or window. Zoom is better here. There's actually a zoom trig, which is 7. That's a better one. It gives you like the window you kind of want for trig functions.
Mm-hmm.
And you can see kind of like the graph I did there, it's hitting it twice. Now I'm going to zoom in on just the first quadrant because I want to really like get to where you see this. Let me go to make this 2. You don't have to change these, but it helps me to kind of show you what we're going to do next to find it. So you go to secant calc, which is under trace, and then you go to intersect, and it says first curve. So you can choose whichever curve you want. Actually, my window is no good here. Let me change my window because you can't see enough of it. Let's go -2. Sorry about that. We couldn't see where we were on there.
Mm-hmm.
Secant calc intersect. And then, okay, so now I can see where I'm at. So first curve, okay, I'm just going to get kind of more. So all you have to be is nearby. Like we know the intersection is right there. You don't have to be right on top of it. You hit enter. Second curve, you have to be on the second curve. And again, you do not need to be right on top of it, just nearby in the neighborhood. And you always guess where your second one is. So 1.26610. To find the other one, you have to do the same thing. Second calc, intersect, and then you got to get close to it. You got to get, in the neighborhood, so to speak. So look, I'm pretty far away, right? I hit enter. There's the other curve. I hit enter again, guess, and it'll give me that point. You got to be close, not too far away. Is there anything on that you would like me to cover again?
No, that makes sense now.
Okay. Uh, 36, I would recommend using a calculator for. So let me show you how I would do. Let me go back to this, I guess. Are you seeing my calculator?
Yeah.
Okay. I am not. Where did it go? There it is. Okay, so I'm going to quit out of this. So if you're looking at 36, you need to make sure you're in the right mode. Okay, so your mode is in degrees this time, and you go enter. Great. So I can quit. Sine of 15, 14, 15. Okay. All right. So we want that number, right? Now, note if you're looking at A, B, C, and D, they're all kind of similar. Okay, so if you can actually enter all of it in at one time, and I'll try to show you that here. So I'm going to do actually the bottom one first. Second square root 2 minus square root 3, and then I'm close parentheses /2. Okay, and see how that worked? That worked nice, but let's assume it didn't work. Rather than re-entering it, you can hit second entry, which is down here by the enter, and it'll give you the same thing. Now you can go back and edit it. So see how letter C, the only difference is the plus? I'll do plus. I get that number. Second entry gives me the previous line. So notice letter B has a minus there. So I can put a minus right there. To put a minus out in front, you actually have to insert. It's a little clumsy. It's not like phones. We thought this technology was really cool back in the day. Now it's like really archaic, but it works. Okay. And so if you're comfortable entering that, and I think yours might even have like more of like a math mode where you can make it look like the equation.
Yeah.
Do that. Do whatever you think you're going to do to be able to get this down, because it's it's for a grade. It matters. Okay. All right, 37. Where's 37? There it is. All right, let me snip a few of these in. Go back to sharing my screen. And this is a common final exam, so every student's taking it in your like all the algebra 2 trig students.
Yes.
Okay. So this one again, I would probably put tangent 22.5 in my calculator and just figure out which one it is.
Okay.
38, I would graph. So I'm gonna make some notes. I'll just say calculator and then calculator. This one is Y1. This one is Y2. Okay, and then you want to make sure your window is good. So because it's going up to 19, tangent kind of looks like that. You got to go way up to hit it. Like it's not going to be visible. You're going to have to stretch your window. So make sure you use your zoom and your window appropriately on that. However, having said all that, you could put these numbers in for X, but your mode would have to be in radians.
Okay.
Maybe that's even faster. Okay, 39 we'll look at next.
Okay.
You may want to start looking ahead just to see if there's anything upcoming that you want me to get to.
Okay.
But I'll start working on this one. So this equation, you want to isolate cosine x. So it becomes cosine x equals √2/2. And you're looking for all the places on the unit circle where cosine is square root 2/2. So it's there at pi/4, but it's also there at this point, which you get by going all the way around to 7 pi/4. So once you've identified this, it's really just a unit circle lookup.
Okay.
Again, you could just try the numbers in here. Your mode, though, has to be in radian. .40 is similar. 41 is more complicated. I'm pretty sure your school just reuses the same file every year on this. I mean, this is the same review every student I've ever helped has given me. So I do think the calculator strategy is good, but this one right here is slightly different. You still solve for cosine, but you get it down to cosine squared x equals 3/4. And you do have to take a square root of both sides. But as a reminder, it's plus or minus square root 3/4. So now it's same deal. So this is plus or minus square root of 3/2. You look for those places on the unit circle. It looks like, I think this is it.
Okay.
Yeah.
Yeah, I think so too.
But again, you could also just plug these in. Like if you plug in pi/6 and it works, you know it's either A or D. If it doesn't work, you know it's either B or C. And then you just look for the ones that are similar and different. All right, so with the time remaining, is there a problem or 2 or 3 or 4 that you want us to just hit on?
We could start with number 65. That's the one that I see.
All right, got it. Lovely. Arithmetic sequences. All right, so find the 30th term of the arithmetic sequence. So the formula for the arithmetic sequence is A1 plus n minus 1 times D. You find D by subtracting next minus previous, so 16.3 minus 12.9, which is 3.4. A1 is your first term, so your AN is 12.9 plus n minus 1 times 3.4. And so to find the 30th term, you put 30 in for n. 12.9 plus 30 minus 1 times 3.4. I mean, this is definitely a calculator problem here. There's another shortcut, but we don't have time, but definitely get this down. This is key that you be able to do that. 66. Okay, the 12th term of an arithmetic sequence is 13. So a sub 12 is 13. And the 5th term is 6. So what you have to just convert each of these into an equation. So in this first one, they're telling you that n is 12. And a sub n is 8. A sub n means a sub 12, which is 13. So it's 13 equals a1 plus, instead of n, it's 12 minus 1 times d. And I'm using this an equals a1 plus n minus 1 times d. So the second equation is 6 equals a1 plus 5 minus 1 times d. So these both reduce. It becomes 13 equals A1 plus 11D. 6 equals A1 plus 4D. You subtract the equations. You find that D is 1. And then you go back and use one equation or the other to find A1. So since D is 1, I'll go back and use this one here. 6 equals A1 plus 4D. 4 times 1 is 4. Subtract 4, so A1 equals 2. Why do we do all that? Because we need the equation. We need AN equals 2 plus N minus 1 times 1. And to find the 22nd, 22th, okay, 22th term is N equals 22. So 22 minus 1 times 1 plus 2. So 21 looks like it's 23. If you were really uncertain, you could probably write out the numbers. I don't recommend that though. I mean, that's actually a little bit extreme. Probably do that. We don't have any more time to do problems, but I'll remind you that your calculator will do summations.
Mm-hmm.
It's that sigma symbol. Hopefully you've done that before. The old way was the sum sequence thing, which is really, you don't want to do that, but you probably know how to find that, hopefully. Great. And then for geometric sequences, you have your a different form. Your AN equals A1 R to the N minus 1 power. And your R is the next divided by the previous.
Okay.
All right. I think that's it. If you have time, try to work through the rest of these, but you probably can do great as you've been doing. So
thank you.
Are you doing anything fun this summer?
I'm not sure yet. I think we were supposed to go to Europe, but I don't think that's happening this year. So we'll see.
Okay. Well, Southern Arizona in the summer. Hopefully you can get out.
Yeah, I hope so too.
All right. Well, thank you so much for letting me help you. I'll send you the notes here shortly and I'll see you next time.
Perfect. Thank you.
You're welcome. Bye now.